is Abhishek Yadav, and today we are going to see compiler lab experiment number 2. So in this we have to make a symbol table generation. So a symbol table is a data structure containing record of each identifier with fields and attributes identifier. The attribute may be given the information about the storage located of the identifier, data type and scope of the identifier. By using these records, each identifier can be retrieved easily and quickly. During lexical analysis, the identifier will be found and stored into the symbol table, but attributes will not be stored in lexical phase. The compiler of the assembler will have their own symbol table. The expression will give an input and output obtained will be containing the table of information about the identifier. So the algorithm for this is get the expression from then separate each and every token. If the token is the ID, and create enter symbol table and enter the identifier and name its corresponding data. Check the data type and each identifier and assign the corresponding memory location. Check whether the identifier have a value. If so, enter the value to the identifier. If the token is already entered, then we will avoid entry. So basically it is the progression of the last experiment we have done, in that we have already done till the token separation. Now we have to identify, then we have to create an ID and enter it into the symbol table, then check the data type of the identifier and assign the corresponding memory location, and then whether it identifier has the value, then we have to enter it. So this is the program. So from here it starts int min, here it starts. So last time, as you can see, we have used these many operators and punctuations, but this time we have used a different approach. So till here we have already seen that it will going to take the command, the program from the programmer, and it is going to enter it with a separation, that is void and space, and after that until unless it types small q. Last time it was capital Q. So after that we are going to copy it into the character array, same as previous, and then we are going to find the token, like what it is, keyword or a identifier or a operation. So but in this case we have only used keyword and identifier. So for until unless it is not a token, so it is going to check over here that it is not a token, then it is going to continue and it is going to compare that. After that, if it is not a token, then what else it can be. If there is an equal to, if there is an equal to, then it is a keyword, and if it is a keyword, then the previous part is a identifier, and the value of it will be from the next problem. And similarly is the case with equal to. So either it can be equal to or comma or semicolon. So in this case we have taken only these three, or it can be done with the space. So it will identify the identifier and the initial value, the default value we have given it to 0, and it goes on, and then it compares the, if it is space, then it will skip the rest of the part, and then over here it just completes the loop. So let's check, compile it and see. Compilation again. So we can enter the program here. So int a comma b comma c equal to 0, and we end it, and we give us some float z, again float x comma y equal to some value 4 0. So it gives us the table. So here we have int identifier a, b and c, and the value are 0 0 and 0, because we have already given the default value as 0. Let's do it one more time and let's see. So here it ends. So here we can see int a and the value 0, int b equal to 0, which we have given default value, and the c, which we have given the value 5, it is taking over here, and the float identifier. So here qf it is taking as an identifier because it is not separate, it is not taking as that, and the value default value it is giving as 0. So that's all. Thank you.